Okay, this is MD10 week 3 independent activity. The first one asks you to evaluate 2 to the third power. So I rewrote it, expanded it out here, which is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, and that's our answer. The next one here, we have um, find the square root, question 2. Find the square root. So I rewrote that as 9 squared. Square root of 9 squared is 9. Question 3, find write in exponential form. So I have 2 times 2 times 2 times 2. The exponential form would be a to the n. In this case, the number of times it's being repeated is 4. My base is 2. So an exponential form is going to be 2 to the 4th power. Question 4, I mean. Evaluate the following. Negative 3 squared. It's the same thing as negative 1. What's being repeated is the 3. So I have negative 1 times 3 times 3, which is going to be negative 1 times 9, which is negative 9 for my answer. Number 5, they ask you to evaluate a function. There's number 5 there. Evaluate that function. So we have quantity 2 to the 4th. We have quantity 2 to the 4th raised to the 2nd power. The 2 to the 4th is being repeated. We can expand it out and see that 2 to the 4th here is the same thing as 16. So 2 to the 4th is 16. So what I really have is 16 times 16, which is 256. Question 6 asks us to evaluate negative 3 squared raised to the 3rd power. Okay, so negative 3 squared is really negative 3 times negative 3, which is a positive 9. So we can plug back in. What I really have there is negative 3 being repeated 3 times. 9 times 9 times 9, which is 81 times 9. My final answer there is 729. Let's go on to number 7. With the expression, the square root of 8 times 18. 8 times 18 divided by 4. I expanded out the 8, this would be 2 times 4, and the 4 is canceled. So what I have here is 2 times the square root of 2 times 18. 2 times 18 is 36. The square root of 36 is 6, and that's our answer there. Number 8, simplify the expression. So I have 5 times quantity 4 squared minus 3 squared divided by 27 divided by 9 times 45 divided by 27. I simplified my numerator first. So I have 5 times, take care of the exponent in the parentheses. 4 squared is 16. 2 to the third is 8. So I have 16 minus 8. And that simplifies to 16 minus 8 is 8. So I have 5 times 8. In my numerator, 5 times 8 is 40. And I start working on the denominator. 27 divided by 9 is 3. Okay. And then 3 times 45, which is 135. So I have 135 divided by 27, which is 5. And 40 divided by 5 is 8. That's the answer there. Question 9. Question 9, I have 4 plus 2 times 10 minus 4 divided by 10 to the third minus 988. So I take care of what's in my numerator first. 4 plus 2 is 6. 10 minus 4 is 6. 6 times 6 is 36. Take care of my denominator. 10 to the third is 1,000 minus 988. 1,000 minus 988 is, so you can see that, it's 12. So 36 divided by 12 is 3. And let's go on to the next one, problem 10. Here we have Joseph. Here we have number 10. We have x to the 12th divided by x to the 8th. It simplifies to x to the 4th. Let's take a look at number 11. Number 11. Mm-hmm. Okay. That's a typo, but the same answer. Here we have, in mine, I have negative 10 raised to the 3/2 powers, which is the same thing as negative 10 raised to the, I'll break up this product here. Break up this product. So I have negative 10 raised to the 1/2 power, raised to the 3rd power. I cannot take the square root of a negative number. I cannot take the square root of a negative number. So the solution does not exist. Okay. Reason being is that when you have a square root, you ask what number when repeated multiplication. Multiplied by itself will give me that number. That means if it's the same number, they have to have the same sign. And if they have the same sign and you multiply, then it's positive. But that product there, that result is negative. So there's no way you can multiply two numbers with the same sign and get a negative number. And that's for number 11. Number 12, I have a negative 1 times negative 100 raised to the 1/2 power. Here again, same thing. You can't take the square root of a negative number. It doesn't exist. Number 13, you have to watch carefully here to see what your base is. See what your base is. In this case, that's my base. In this case here, just as x is my base. So when I rewrite this, I use this property here. Product of a power. Product raised to a power. It's supposed to be a b. It's going to be a to the n times b to the n. So I rewrote this here. So I have 144 raised to the 1/2 times x to the 1/2 times -6 times x to the 4/5. So that 144 raised to the 1/2 is the square root of 144. And I have -6 here, so I rewrote them. Square root of 144 is 12 times -6 times x to the 1/2 times x to the 4/5. They have the same base, have different exponents. I rewrite them so I can add them together. So 12 times -6 is a -72. So here what I have is 5/10 plus 8/10, and I add them together. And that gives me 13/10. So in this case, the answer for the C is -72, and the answer for A is 13/10. And that's number 13. Let's take a look at number 14. So I have the expression, I have x raised to the -3/2 divided by x raised to the -6/5. Since I have negative exponents, I'll use this rule here. All right. It means it belongs to someone else who's raised to a negative exponent, so I'll flip them. And that's what I did here. To flip them now, I have positive exponents. And since I'm dividing, I subtract 6/5 minus 3/2, the exponents. They have different denominators, so I'll find a common denominator, and one becomes 12/10. 12/10 minus 15/10 gives me a -3/10. So I have x raised to the -3/10. So for my answers, one answer is -3/10, where x is equal to -3/10, and the other answer is 3/10, where the problem is going to be 1 over x to the 3/10. So there's two possible answers there. And that's number 14. Number 15, write as exponential notation. So I have 1 divided by the 9th root of 21 raised to the 6th power. So I'll rewrite this one here. Rewrite that the root as raised to the 1/9 power. Okay. And so then I bring it up to the top here. So I have 21 to the 6 raised to the -1/9 power. And I end up with 21 raised to the -6/9 power. And that's my answer there. Part number 16. In the spreadsheet above, what is the amount of money borrowed? It's 20,000. In part B, in the spreadsheet above, what are the number of years the loan will be repaid? It will be repaid in 15 years. And spreadsheet above, what is the interest rate? The interest rate is 3.4%. In part D, what formula? How many periods are there in 1 year? So they see 12 for the number of periods. And then they ask the question, What formula would you use? So I wrote out my payment formula there. And then I have my variables. Okay. Then I assigned equality here, values to the variables, principal, P, R is the rate, N is the period, and T is the term. Then I replace them with the variables there, the values there. Now, because it's Excel only gives you one line to write everything on. So in my numerator, I have principal times the rate divided by the period. Then I have this huge fraction bar divided by all this underneath it. So I'll put in parentheses here, here, and here. So that everything inside that is my denominator. And I just rewrote it after that. And they use that caret symbol, that little caret, that's my exponent here. And that's my final answer there. In question 17, we take that information. And they want to see a payment formula. So I just map it back and I plug back in. And that's what the formula looks like. And that's number 17.